This is Dr. Mohan from AC Department, Institute of Aeronautical Engineering. Today, we are going to discuss about the Fourier series of different method. Last class, we studied for the Fourier series of trigonometric condition as well as of exponential Fourier series. This class, we should see exponential Fourier series, cosine Fourier series, continuous time Fourier series, Dirichlet condition, cosine Fourier series, as well as of symmetric condition or wave symmetric. Here I represent for the two type of cosine Fourier series. One is represented as a symmetrical as well as a anti-symmetric condition. Both the condition we should study here. First, we must go for the exponential Fourier series. The exponential Fourier series, we should go for only the periodic signal. So that's why I should take for the periodic signal as a x of t with period is represented as a capital letter T. The exponential Fourier series can be defined as x of t is equal to summation of n equal to minus into plus into c of n e power jn omega 0 t. Here I represent for the omega 0 t. This is called for the analog omega 0 t. Because of we studied for the analog signal, that is continuous time Fourier condition. So this case c of n is represented as a Fourier series coefficient of exponential condition. This case c of n is equal to 1 by t integration of minus t by 2 plus t by 2 x of t e power minus j n omega 0 t dt. So why we take for the minus t by 2 plus t by 2 for the integration? Because of the signal is represented as a periodic case. That is I call for the capital letter T. This t I should divided for the two part. One is t by 2 comma minus of t by 2, that is plus t by 2 minus t by 2. If we add both, we get for the capital letter T. Yeah, that's why we write for the coefficient of exponential Fourier series is represented as c of n equal to 1 by t integration of minus t by 2 plus t by 2 x of t e power minus j n omega 0 t dt. We should take some example to analyze for the exponential Fourier series. Here I take for the ramp signal. So the ramp signal is present for the 0 to 1, the amplitude is equal to 1. So if 0, it's what the time period is going to increase, same that amplitude also is getting to increase together. After some duration, that is some time 1, that will be represented as 0. Then I write for like this case. So after next duration, this is 1t. So another t, it will be same, this signal is going to repeated for the another time. So that's why this signal is represented as a periodic signal. That period, fundamental period is represented as a capital letter T. So this is t, another t, then another t. Here I write as a 1t, 2t, 3t. But the same signal is going to repeat it for the every time. So due to that case, what I am doing, I take for the one period only to analyze. After that, I make it for the sum. Then we get for the complete exponential Fourier series expression. So I take for the only one this period. What is that? It's represented as started for 0. It's increasing, exponentially increasing. After duration of 1, it's getting to decrease. That the case I represent as the q. This portion I represent as a q. Then this is I represent as a p. This is I represent as a t. Then we take for the pqt. The pqt is one ramp type of signal. Now we should find for the period. The period capital letter T is equal to 1. Why? Because of 0 to 1 it's going to happen. This is a 1t. Then omega 0, we know the formula 2 pi by capital letter T. T is represented as a 1, then I write as a 2 pi by 1 is equal to 2 pi. So we know for the T as well as omega 0 both condition. Next, after that we need to analyze. So this signal, it doesn't have for the any mathematical expression. That's why I consider for this signal as a straight line. We know the straight line equation, that is represented as a y minus of y1 divided by y2 minus of y1 equal to x minus of x1 divided by x2 minus of x1. So now we represent as a, this is x, then we represent as a y, then based on the condition, I made for the equation as a mathematical model of our waveform as the coordinate PQ as in the figure. The coordinate of point P I represent by the 0, 0 because of it start for the xy direction, that is this direction as well as this direction is started for the two coordinate, that is 0, 0. Then after we go for the coordinate Q, that Q is equal to 1, 1. So this is what will be happen, the time period of 1, at the same time amplitude also 1. These two are meet together, then this value is equal to Q, that will be represented as 1, 1. I write as. So then on the substituting the coordinate of the point PQ in a straight line equation, we should get like this form. The x of t minus of 0 divided by 1 minus of 0 is equal to t minus of 0, 1 minus of 0. Now we got for the x of t is equal to t as a straight equation. Now this condition x equal to t, then y is represented as x of t. Now we need to evaluate for the C0, that is the initial condition of exponential Fourier series, that is equal to C0 is equal to, we know the formula, that is represented as a 1 by t integration of 0 to t x of t dt is equal to 1 by 1. The t we found from the signal, the t equal to 1. Then after the x of t we need to found that value is equal to t, then you should substitute for the t here. That value is represented as 1 by 1 integration of 0 to 1 t dt. If you make to integrate t square by 2, you can substitute for the interval of 0 and 1. Finally, we got for the 1 by 2. Next, we need to evaluate for the C of n. The C of n is equal to 1 by t integration of 0 to t x of t e power minus n omega 0 t dt. This formula we know for the exponential Fourier series coefficient. Based on this condition, we should substitute for the 1 by 1, that is t is equal to 1, the x equal to t, the interval is represented as 0 to 1 as a waveform. See, the waveform is 0 to 1, the interval. Then we substitute for the 0 to 1, that is t equal to t x of t is equal to t e power minus j n. The omega 0 is represented as 2 pi t dt. Then this one is going to using for the integration of u v, that is u v du model. Then first we should integrate for this model, that is u model. The v model I put for here e power minus j n 2 pi t divided by minus j n 2 pi t. Then 0 to 1. Then after we integrate with t, then remaining portion it will be going to keep same as integration of 0 to 1. T integration is represented as, that is v dash is represented as 1. Then e power minus j n 2 pi t minus of j n 2 pi t dt. Then we need to substitute for the interval of 0 to 1 for this portion. So then we got for the e power minus j n 2 pi divided by minus j n 2 pi plus this 0 portion is represented as 0 because of t is equal to 0. Then t value is represented as 0. Then the next portion then represents as 0. Next after you can make to integrate for this part. Then we should substitute for the interval of this portion. We get for like this formation. So finally I should write as the equation as j e power minus j n 2 pi divided by 2 pi n plus e power minus j n 2 pi divided by n square 4 pi square minus of 1 by n square 4 pi square, right. We should simplify for all the values. So for this whole value, we need to simplify. Finally, we got for the this two getting to cancel. That is this portion getting to cancel. Remaining portion only is present for the j n 2 pi. Now c of n is equal to j n 2 pi. We got this value. We got. Then after we write for the values of minus as well as a plus in the case c of 1 equal to, we should substitute n equal to 1 by 2 pi. C of 2 is equal to j divided by 4 pi. C of 3 equal to 6 divided by. At the same time, minus n also, minus 1. C of minus 1 equal to j divided by minus of 2 pi, comma, C of minus 2 equal to j divided by minus of 4 pi. C of 3 is equal to j divided by minus of 6 pi. And finally, I should substitute for the our exponential Fourier series. X of t is equal to summation of n equal to minus into plus into c of n e power j n omega 0 t. So here we know the c of 0. So at the same time, minus as well as a plus direction. Both the direction we need to substitute. That c of 0 I should take for here. This is represented as a minus direction. So c of minus 1, c of minus 2, c of minus 3, c of minus 4. This direction c of 1, c of 2, c of 3, c of 4 like that. So we should substitute for that what we are going to finding for here, these values. Then after we need to simplify for this equation. Then after substituting those value, I take it out for the what the common values are present. The 1 by 2 I take it out. There is no relation between for any value. Then after j 2 pi, for here also j 2 pi is there. Here also j 2 pi is there. We take it out. For the remaining portion, this portion and this portion we need to add. E power j 2 pi t minus of e power minus j 2 pi t plus next portion I should take for the j 4 pi. Then remaining portion this one and this one. Here is j 4 pi is there. So what is it? E 1 j by 4 pi e power j 4 pi t minus of e power minus j 4 pi t. Same like that one we should write for all the values. After that we need to simplify for our equation. This we know the case of the sine of theta is equal to e power j theta minus of e power minus j theta divided by 2j. So this format we need to write for our equation. That is, I take it out for the 1 by pi. Here is e power minus j 2 pi t minus of e power minus j 2 pi t minus 1 2 pi 2j. I write here. Same like that 1 by 2 pi. So e power minus j 4 pi t minus of e power minus j 4 pi t minus upon 2j. Like that one I write for all the cases. Then after this portion, see this portion is like our sine term of Euler form. Then I write for the value sine of 2 pi t. So 1 by 2 plus minus 1 by pi sine 2 pi minus this minus I write here 1 by 2 pi sine of 4 pi minus of 1 by 3 pi sine of 6 pi like that one I write. So in this all term how the pi is a common. I take it out the pi also 1 by 2 minus of 1 by pi. This is also minus, this is minus, take it out sine 2 pi t plus 1 by 2 sine 4 pi t plus 1 by 3 sine 6 pi t up will be. So now we got for like this waveform. This waveform, the Fourier series value of exponential condition is represented as this is the case of x of t. So if we get for the waveform, then we may write it for the mathematical equation to use for the exponential Fourier series. The purpose we are using. Now, if you see this one, it will be consist of frequency. Easily we can consist of frequency and amplitude and how the signal is going to react. Everything is going to measured through the exponential Fourier series. Next condition, cosine Fourier series. Now, cosine is represented as x of t value is equal to a0 plus summation of n equal to 1 to infinity an cos n omega 0 t plus theta n. Now, a0 is represented as a DC component. This a0 is represented as a DC component. A of n is represented as a harmonic of amplitude or spectral amplitude. So this harmonic of amplitude or spectral amplitude, it's present for the up to infinity level. It's so many harmonics are present. So when we go for the frequency modulation, we should do for the cosine Fourier series modulation type. So this cosine type modulation, it's producing for the harmonic value of amplitude or harmonic value of frequency cases. So that's why we call for the A of n is harmonic amplitude or spectral amplitude. Then theta n is phase coefficient or phase angle or spectral angle we should represent. So this case we take for the some example. So here I take for the one example that is represented as a half wave rectifier. I take for the half wave rectifier. We know half wave rectifier. The half wave rectifier is going to present for the 0 to pi or the 1 half. Another half it's going to start with the 2 pi to 3 pi. 2 pi. So this intermediate of pi to 2 pi, the value is represented as 0. So now I should take for the full half wave rectifier to find the cosine Fourier series. Now this case we need to find for the omega 0 as well as of t. So here what is the t is present? It's take for the entire duration, the t. This it will be what we are going to finding this value of the signal. It's going to repeat it for the next cycle. Okay, that is 2t cycle will be. So once if we find for the t, then there is no case to find for the another case. We can use for the summation. So this case, first we find for the fundamental period. Capital letter t is equal to how much duration is present? Up to 2 pi is present. Then t is equal to 2 pi I write. Next, we should find for the omega 0. That is analog omega 0. What is the analog omega 0? We know that formula omega 0 is equal to capital letter T. So the omega 0 equal to 2 pi by capital letter T. So 2 pi, then T is equal to we find for here. Then substitute for the omega 0 equal to 2 pi by 2 pi, then is equal to 1. Okay. From the given signal, this signal I represent as a sin omega t. Okay, A sin omega t. The A value is represented as amplitude. Now we need to find for the omega. Omega is represented as 2 pi by t. So omega is equal to 2 pi by t. T we know that t equal to 2 pi. You can substitute. Then value is represented as 1. The omega equal to 1 and the amplitude is also 1 because of the amplitude is represented as 1. We can substitute here. Then we get for the x of t. The x of t is equal to 1 into sine of t. Now we should evaluate for the cosine Fourier series. What we do for the first case, we must find for the a0. Then this case of a0, we need to find for a0. After that, we need to find for the a of n. First a0, we know the formula 1 by t integration of 0 to t x of t dt. We know x of t, that x of t is equal to sin t. Then a0 1 by t is represented as 2 pi. I write as 1 by 2 pi integration of 0 to pi. So here I am not taken for the 2 pi because of the amplitude value is 0. Pi to 2 pi is amplitude value is 0. If a amplitude value of 0, if we take for the integration of another half cycle, this is a first half cycle. We take for the another half cycle, this amplitude 0, that's why it will be represented as 0. Then we need to find for this duration only is enough. So that's why I write as a limit is represented as 0 to pi sin t dt. That is 1 by pi 2 pi. So you do for the integration, that is called for the sin t is equal to minus of cos t. I write for the minus of cos t 0 to pi as a limit you must substitute. Then if you substitute for the 0 to pi, that is pi is minus cos pi plus of cos theta cos 0. Then this value is represented as this is minus of cos pi is represented as minus 1, cos 0 equal to 1. So minus here is minus 1, minus into minus equal to plus. Here is represented as 1. So total how many is represented 2? Then these 2 are getting to cancel. Then finally we get for the a0 is equal to 1 by pi. Next condition, we need to find for the a of n, that is cosine Fourier series coefficient a of n is equal to 2 divided by t because of 2 time. we need to we need to find if we are going to receive for the signal as this case 0 to, that is minus infinity plus infinity. So minus infinity to plus infinity, but our case is represented as only 1 to infinity, that is 0, we take it out. That's why we need to divide by the 2. That's why I should write as a 2 divided by t integration of 0 to t x of t cos n omega 0 t dt I should write. So 2 divided by capital letter T is equal to 2 pi, 0 to pi we should take for the 0 to pi, only 0 to pi only is present for the signal, sin t cos n t dt. Now this is represented as a, this equation is represented as a sin a cos a term is present. So now what we write, sin of a plus b plus of sin a minus b we should write. So that condition I should write for this. This equation is not possible to do for the integration. That's why we need to go for this format. Then I write as a 1 by 2 pi integration of 0 to pi sin 1 plus half n. Here is 1 is there. Here is represented as n. Okay. So sin t, that is 1. Here is n is present. So that's why sin of 1 plus of n as per the statement of the trigonometric formula t, that is sin 1 plus of n t plus sin of 1 minus of n t dt. Now we get for the two sin as well as of cos sin terms, we can easily do for the integration. So if we do for the sin of 1 plus of n, integration is represented as a minus of cos 1 plus of n t divided by 1 plus of n. Next, that is this case, if we do for the sin minus of cos 1 minus of n 1 minus of divided by 1 minus of n t, we write the limit is present for the 0 to pi, we can substitute. After substituting the limit, we get the output like this format. What is it? 1 by 2 pi cos 1 plus of n by 1 plus of n minus of cos 1 minus of n pi divided by 1 minus of n plus 1 by 1 plus of n plus 1 by 1 minus of n. Here is represented as a minus. Then after that we need to simplify for all. So this case cos phi we know that is value equal to 1. Then I write as a that value is equal to 1 by 2 pi minus 1 divided by 1 plus of n minus of 1 by 1 minus of n plus 1 by 1 plus of n plus 1 by 1 minus of n I write. If we simplify, then we get for the 0. If we add for all value, we get 0. See what is that? These two are getting cancelled. These two are getting to cancel. And finally this value 1 by 2 pi into 0, that value is equal to 0. For the case of n is odd condition, if for the case of n is even, what will be happen? 1 by 2 pi 1 by 1 plus of n plus 1 by 1 minus of n plus 1 by 1 minus 1 plus of n plus 1 by 1 minus of n. Now we can add for all. Finally we got for the 1 by 2 pi 2 time of 1 plus n plus 2 time of 1 minus of n. Then here I need to complete solution. I take for the cross multiplication for this one. So 1 by pi, then 1 minus of n plus 1 plus of n divided by 1 minus of n whole square. So this value is represented as a, after simplification of this value, it will be, I write as a 2 divided by pi 1 minus of n square I should write. Now a of n is represented as a 0 when n is odd. If n is even, the value is present for the 2 divided by pi 1 minus of n square I should write. So this is a way we may represent for the continuous Fourier transform. In this continuous Fourier transform cosine condition, what will we do the process? So now I take for the continuous signal. That signal is represented as e power t. Okay. For complex exponential signal or tangent function of linear time invariant system, I should take e power st. I write for the function of h and produce the output is represented as y of s. This y of s is equal to x of s into then h of s. I write for the Laplace transform condition. Okay. So this case we know x of s is equal to e power st we got for here. So I should write as a y of s equal to e power s t h of s we made. This h of s is called for the system performance. We call for the system performance. So that's why I mentioned here. In h is a linear. It's calculating y of t for combination of complex exponential case. That will be, I write as c1 e power s1 of t plus c2 e power s2 of t. Then that value is equal to c1 h1 of s1 e power s1 of t plus c2 h2 of h s2 of e power s2 t. I write. So now if we have for the multiple case, then I write it's represented as a summation of n c of n e power st. It tends to summation of n c of n h of s n e power s of n t I should write. So this whole term I make it like this form. This whole term I make it like this form. Now the h is independent scaled up each e power st exponential computational by the differential calculation. That will be generally we call for the exponential component by the different complex value. If the different complex value number is present, I should write for the your h of s n is set of c only. The c is represented as a it's belong to all condition. Now the Fourier is demonstrate that the arbitrary signal y of t can be write as linear combination of harmonic complex sinusoidal. If harmonic complex sinusoidal, the function I should write as a f of t. That f of t is depends upon the system performance. So the f of t is consist of summation of n equal to minus infinity to plus infinity c of n e power j omega 0 n t. Now this omega 0 is represented as a digital format. So what we represent here, we write as a continuous time signal, but we got for the discrete time signal of exponential series. So here I use for the n. Why? Because of n time is going to vary, or n time is possible to do the harmonic. Now due to this case, I write omega 0 is represented as a digital omega 0. Omega 0 is represented as a digital case. That omega 0 is represented as a 2 pi by t is a fundamental frequency. Now c of n is called Fourier coefficient. Now we need to find the coefficient of Fourier series expansion involve some algebraic manipulation of the synthesis formation. So now we can multiply both sides of the equation for e power minus j omega 0 kt. So this equation we should multiply for the both sides. To take for the exponential case of this condition, we multiply for the both the side is e power minus j omega 0 kt. Now f of t e power minus j omega 0 kt is equal to n equal to minus infinity c of n e power j omega 0 n t e power minus j omega 0 kt. We need to integrate both sides over the interval of capital letter T. Okay, both sides we need to integrate. The limit that is called for the period is represented as a fundamental period. Fundamental period where is going to happen 0 to capital letter T. So integration of 0 to t f of t e power minus j omega 0 kt dt is equal to integration of 0 to t summation of n equal to minus plus c of n e power j omega 0 n t e power minus j omega 0 kt of d of t. So now we need to interchange for sum as well as of integration in the right side. Okay, so this left side there is no changes. In the right side we need to integrate interchange for the integration as well as a summation. So summation we take it out, n equal to minus into plus into c of n is a constant. Integration of 0 to t e power j omega 0 n minus of kt dt I should write. Now I take n is equal to k. We will have the set of n is represented as a k. If the condition n equal to k, then this portion, the entire portion is represented as one fundamental period. That is integration of 0 to t, capital letter T, e power j omega 0 n minus of k t dt is equal to t. Now, if n is not equal to k, we'll have the set of n is not k, then 0 to t of integration e power j omega 0 n minus of k t dt. Now, this value is, I should write as a sine as well as a cos term, because of e power theta is equal to sine theta, e power theta is equal to cos theta plus of j sine theta. We should know for the Euler condition. So, that format I can take for this one. We should substitute for the e power j omega 0 n k is represented as a cos omega 0 n minus of k dt plus j integration of 0 to t sin omega 0 n minus of k t dt I should write. Now, this case, the cos term is a even condition. That condition, the values are 0, which hold for the integral involve the sine function. Then we consider the following about our integration or integral. Then integral of 0 to t e power j omega 0 n minus of k t dt is represented as a capital letter T. If n equal to k, 0 otherwise. Now the set of value n is equal to k we take. That case, integration of 0 to t f of t e power minus j omega 0 n t dt is equal to t into c of n I should write. That is a exponential case. So, in this case, the Fourier series coefficient, the general Fourier series coefficient I should write as a c of n. The c of n we know 1 by t of integration 0 to t f of t e power minus j omega 0 n t dt. Now, the continuous time Fourier series is synthesis formula expression as continuous time periodic function as sum of continuous time. Discrete frequency complex exponential also is going to present. That's why I write as a f of t equal to summation of n equal to minus c of n e power j omega 0 n t. Now, the coefficient, Fourier coefficient c of n is represented as a c of n is equal to 1 by t integration of 0 to t f of t e power minus j omega 0 n t dt I should write. Now, we should go for the Dirichlet condition. For Fourier series to exceed for the periodic signal, it must satisfy for the certain condition, and they are: first case, x of t, the function x of t must be single value function. Yeah, x of t must be single value function. What is it? X of t here, the x of t is represented as a single value. So, the x of t, if we represent by the single value, then we write as a x of t is equal to some function amplitude sine of omega 0 t. That will be we represent by here as single value function. Then x of t is as a only finite number of maximum and minimum. That means our integration is going to present for the only fundamental period 0 to t, or integration minus t by 2 to plus t by 2, or its represented as 0 to 2 pi. Okay, or its integration of minus pi to plus pi. So, anyway, that will be how the maximum and minimum values are finite values. Next case, the function x of t has finite number of discontinuities. See here, for here what we write, f of t is equal to n equal to minus plus mu c of n e power j omega 0 n t. This is represented as a finite number of discontinuities. We can say that is 0, 1, 2, 3. The discontinuity is present for the 0 to 1 is the interval is 1. Same it will be going to repeat it for the next case. So, that case we kind of say finite number of discontinuity. Then finally we call for the x of t is absolutely integrable over the one period. Okay. So, we taken for the only one period to integration, whether it's represents a fundamental period 0 to t or minus pi to plus pi or 0 to 2 pi or it may be 0 to t. If same, it will be going to repeat for the next cycle. So that's why we are using for the summation. So that the case I represent as absolutely integrable over the one period. If we take for the absolutely integral over the one period, then the value is always lesser than of infinity. So the integration of 0 to t, absolute value of x of t dt is less than of infinity only. The signal consists of before infinitive, that is less than value of infinity of our absolute integral. So next we studied for the cosine Fourier series. I said here is a trigonometric, already we discussed, but even though we may go for the trigonometric condition, the x of t consists of sine as well as of cos term for same frequency. The x of t I represent as a0 plus summation of n equal to 1 to infinity a1 cos n omega 0 t plus bn sin omega 0 t. Now we write for the a0 as well as of a of n, a0 as well as of a of n, what we represent. So then a0 there is no problem. Then a of n I write as a root of a of n square plus b of n square is made. We take it out. What the remaining part? The a of n divided by root of a square plus b n square, a n square b into what the sine cos term, it will be right. Next term plus of b of n divided by root of a n square plus b of n sin n omega 0 t we write. Okay. So now if we take for the if we do for this case, we need to substitute for the a0 is equal to capital A0. A of n is equal to root of a of n square plus b of n square. Then theta value is equal to, that is theta n is equal to 1 tan inverse of b of n divided by a of n. So now I should write as a minus of sin theta is equal to b of n divided by root of a n square plus b of n square. And cos n sin theta n is represented as a of n divided by root of a of n square plus b of n. So finally I concluded for the Fourier, that is a cosine Fourier series term as x of t is equal to a0 plus summation of n equal to 1 to infinity a of n cos theta n cos n omega 0 t minus sin theta n sin n omega 0 t. Instead of this value, I should use for these terms. Okay. Finally, I write for the cos term, cos Fourier series. X of t is equal to a0 summation of n equal to 1 to infinity a of n. This value I should write as a cos n omega 0 t plus theta n. Okay. This is cos a cos b minus of sin a sin b. You write as a, that is cos a cos b minus of sin a sin b. It's equal to cos a plus b I should write. So what the case here is, a is represented as n omega 0 t, b is theta n. So cos of n omega 0 t plus theta n. This term I converted for like this one. This a of n is same, that a of 0 is same. Now what will be happen? We taken for the trigonometric Fourier series, we converted for the cosine Fourier series. Okay. So based on this one, the a0 is called for the DC component because of there is no harmonic is present for the a0. Only it's represented by the DC value. Then a of n represent the amplitude coefficient or harmonic amplitude or spectral amplitude of Fourier series. Theta n represent as a phase coefficient or phase angle of Fourier series. The cos for is also called as harmonic or polar form of Fourier series. This is going to have for the three type of symmetry condition. One is even symmetry and odd symmetry of wave symmetry. The Fourier series consists of satisfied for the three type of symmetry. First we go for the even symmetry. A function x of t is said to be even symmetry. then x of minus t is equal to x of t we write. As the signal, when we studied for the signal, I said the evens, if we have the signal is even, if we take for the minus value, then it's produced for the x of t only. Now then that condition x of t equal to, you take for any signal, it's present for the even as well as the odd signal is there. Now if signal is even, it's getting to symmetry, then x of minus t is equal to x of t I write. So now the signal x of t is equal to x even of t and plus x odd of t I should write. If x of t is even, then x0 of t is equal to 0. Then x even of t is represented as x of t. When the even symmetric exceed the trigonometric Fourier series coefficient, how it's going to happen? Whenever minus of x of minus t, that is represented as odd value. What the odd value is present, all it's represented as 0. What the odd value? The a of 0 and a of n, b of n. This one is represented as odd. This one is represented as even signal. Okay, even component of Fourier series coefficient. When b of n is present in the trigonometric Fourier series, we give further 0. Then a of 0 is represented as 1 by t integration of 0 to t by 2 x of t dt I write. A of n is represented as 1 by 4 by t integration of 0 to t by 2 x of t cos n omega 0 t dt. But b of n is equal to 0 because of that is a sign time. Next, odd symmetry. A function x of t is said to be odd symmetry if x of minus t is equal to a minus of xt. This is consists of odd symmetry. Now we can take for the signal x of t is equal to x of t plus x odd of t. If odd function, then x even values are 0. If we have the odd function, then x even values are 0. What about here? If even value, x odd values are 0. Okay. Then what the output is you are getting? X of t is equal to x odd of t only we get. This case, a of n and b of a of n as well as of a of 0, both values are 0. But only it's exists for the b of n. B of n equal to 4 by t integration of 0 to t by 2 x of t sin n omega 0 t dt we should write. Next, half symmetric condition. So a periodic signal x of t which satisfies the condition x of t is equal to minus x of t plus or minus t by 2. Only we get for the half value of signal is said to be half wave symmetric. The Fourier series expression of half wave symmetric signal consists of odd harmonic only is present. When n is odd, we get for the a of n as well as a b of n. If n is even, a of n, b of n values are 0. That means only the DC component present for the and the signal is even. If signal is odd, we get for the all harmonic a of n as well as a b of n harmonic. A of n is equal to 1 by t into 4 integration of 0 to t by 2 x of t cos n omega 0 t dt. So b of n equal to 4 by t integration of 0 to t by 2 x of t sin n omega 0 t dt I should write. Okay, up to this much I am going to conclude my section. This section we studied for the different type of topic of the Fourier series. Those Fourier series represent as a exponential Fourier series, cosine Fourier series, continuous time Fourier series, Dirichlet condition. Cosine Fourier series how came from the trigonometric Fourier series we studied here. So this case symmetric condition of wave symmetry also we studied. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.